This video is on application security. There are several security measures to implement for applications. First, we have input validation. You're basically writing a code that ensures only properly formatted data may be submitted. It prevents things like injection attacks, and this can be done using allow list or deny list. For example, having a specific range defined by the string length so nothing too large can be put in, or simply allowing and denying specific inputs. This can be done on both server side and the client side. You can also use any lightweight static analysis to enforce your validation rules and look for anti-patterns. And then we got secure cookies. Secure cookies is a secure attribute option that can be set by application server when sending a new cookie to the user with an HTTP response. This will prevent cookies from being observed by malicious actors. Browser will only send cookies with secure attribute when the request is going to an HTTPS page and will not send a cookie with unsecure attribute over an unencrypted HTTP request. It's basically a prevention of cookie transmission over an unencrypted channel, and it could simply be done by setting secure cookie as true in configuration web XML file, for example. It will be more or less the same for PHP, Go, ASP.NET, and Tomcat. And then we have Hypertext Transfer protocol headers. HTTP security headers are a subset of HTTP headers that is related specifically to security. They're exchanged between a client and a server to specify the security details of HTTP communication, providing an extra layer of security by restricting behaviors permitted by the browser and server once the web application is running. There are multiple security headers you can enable to secure applications. Strict transfer security headers, for example, enforces the use of encrypted HTTPS connection instead of plain text HTTP communication. Content security policy header lets you control permitted content sources and other content parameters to ensure protection against cross-site scripting attacks. These are all very simple to enable, but do note that some headers get introduced as temporary fixes for specific security issues, meaning they become depreciated as technology and standards advance. And then we got code signing, which is a cryptographic method to prove a piece of software is authentic. It digitally signs with a private key to provide authenticity to end users that the code originates from a trusted and legitimate source and hasn't been tampered with since it was published. And then we got secure coding practices. Open Web Application Security Project is a nonprofit foundation dedicated to improving software security. They have a quick reference guide for secure coding. It serves as a secure coding kickoff tool and easy to reference. It lists input validations in this as well, but it also lists other secure coding practices like output encoding, authentication and password management, session management, access control, cryptographic practices, error handling and logging, data protection, communication security, system configuration, database security, file management, memory management, and other general coding practices. And then we have static code analysis. Static code analysis is a method of computer program debugging that is done by examining the code without executing the program. The process provides an understanding of the code structure and can help ensure that the code adheres to the industry standards. There are numerous tools for this, like Collaborator, Inbolt, and so on. Of course, it still requires a manual code review as well. Manual code review just involves a human looking at the source code line by line to find vulnerabilities. And then we have dynamic code analysis, which is analysis of computer software that is performed by executing program on a real or virtual processor. For dynamic program analysis to be effective, the target program has to be executed with sufficient test inputs to cover almost all possible outputs. Fuzzing is especially critical. Fuzz testing or fuzzing is a black box software testing technique, which basically consists in finding implementation bugs using malformed, semi-malformed data injection in an automated fashion.